Here we go. We have a question: minimum index of a valid split an element x of an array of length m is dominant if more than half of the element of array R have a value x. You are given a zero index integer array. You can split array into two parts at index I such that the first half is from 0 to I, the next half is from I plus 1 till the last index. So this split, the portion have the same dominant element. Here I to j denotes the subarray starting at index I and ending at index j, both inclusive, and this is we need to return the minimum index of a valid split. So can we split the array in array? So the first array will be this, the next array will be the remaining array. No, we cannot split. The dominant element is 2, but 2 is not in the first array. Then can we split like this? No, we cannot, because in the first segment the dominant element is either 1 or 2, which is not more than half of the elements. Can we split it like this? Yes. The first segment contains two elements, right? So the frequency is 2 and the total number of elements is 3. The frequency, the dominant element is more than half of the elements. So this is a valid split. The index is 2 in this case. What about this? So let's discuss this particular example. So let's build the approach. How can we solve this? So first of all, we need an element and its corresponding frequency. So what data structure we require? We require dictionary or hash map. And suppose I am here. So I want the element and its frequency in the first half and the element and its frequency in the other half separately. So I need two different dictionary, one for the left and one for the right. Yes. So what I will do, I will first store all the elements. Then if I include an element, I will remove it from the second. If I include one more element, I will remove it from the second. If I include one more element, I will remove it from the second. Yes. So let's first build the second map. So second map contains, so let me write it here, because we also need first map. So it contains two frequencies only, one which is 1, 3 frequencies 1, then 1 has 3 more elements, then 7, 1 has one more frequency, then 2, then 1. So 2 and 6. Yes. So then let's build the first array, first map. This is not array, this is map. So I am adding this, but this element will be removed from this. Yes. So I will remove the frequency from this and add the frequency on this. Next I will assume that this is the dominant element. Can this be the dominant element? Can this be dominant element? So the first half length, what is the length? The length is 1 only, and 1 by 2, the element, the maximum element frequency, what I am saying, the maximum element frequency must be greater than half of the elements in both of the segment, right? So the maximum element frequency in this case is 1, which is more than length. What is the segment length? 1 by 2, which is 0. So for the left this is valid, but for the right, is this valid? So we have this much length. So I think this is 8 or 9. So let me check. 1 2 3 4 5 6 7 8 9. Yes, 9. So 9 by 2, so the element 2 frequency must be greater than this. What is the element 2 frequency? Which is 1, which is not greater than this. So this segment is not valid. We need more elements. So I will include it 1 here and I will exclude 1 from here. Not exclude, just decrement the frequency. Can this point be the dominant point? We have this segment, and what is the maximum frequency, which is 1, which is greater than half of the elements. 2 by 2 1. No, this is not true. So I will take one more element, which is 3, and 3 will be removed, or 3 frequency will become 0. Is 3 be a valid point? No. Then again we need more elements. So I am just adding and removing 1 from here. What is the maximum frequency in the left? The maximum frequency in the left is 2, which is what is the range? 4 by 2, which is 2. 2 is not greater than 2. So this segment is not valid. We need more elements. 1 is added here, 1 is removed from here. So let me also draw a line. So I am on to this point, right? So what is the length? What is the maximum frequency in the first segment? Maximum element frequency is 3. So I am assuming this 1 is my segment point, right? So this is my I. The first half is from 0 to I, and the second half is from I plus 1 till n minus 1. So what is the length of this? Length is I plus 1, right? So I plus 1, this must be greater than I plus 1. I plus 1 by 2 means this is the subarray length. What is I? We have 5 elements, so 5 by 2, which is 2. So yes, for first half it is valid, but for second half, is it valid? So let's check. For this, the maximum frequency is 3 only, and what is, so 3 must be greater than length by 2, number of elements by 2, which is 2 only. Yes, this segment is valid. So I will return this segment point 0 1 2 3 4. So I will return 4. Yes, 4 is the answer. Let's code this. So I need map and I will just add all the elements. The next thing will be to make the second array, second map. Oh sorry, this is my first map, or for let's say left, this is left map, new hash map, and this is integer. Next just iterate it. Num size, then add it in the left and remove it from the right. So let me write this braces here. Yes, then let's copy. 1 will be added here, and on the right side the value will be decremented by 1. The frequency will be decremented by 1, and in this case we need a value which is nums of ith value. So this ith value is added in the left side and remove it from the right side. If the left, so I am assuming this value is my breakpoint. So this value frequency must be greater than I plus 1 by 2. Same for right. Right frequency must be greater than, we have total n elements. So let's assume for this we have total n elements, right? So let's suppose I have taken these 2 elements. My I is on index 1 is on index 1. So first I will remove 1, then I also need one more element because this is zero base indexing, and the frequency in the right side must be greater than half of the elements. If this is the case, just return the point, else there is no point, return -1. Yes, let's submit this. Working fine. Then let's discuss about the time and space complexity. In this case, the time complexity is order of n, the space complexity is order of n only. But we can improve this. We can avoid space by using an algorithm called Morris voting algorithm. I hope you already familiar with this algorithm. So I highly suggest you to implement on your own. This is a very simple algorithm and you can solve it in without using any extra space. And that's all. This is just a given hint. If you are not able to do the same, the code is provided in the description box. You can check that out. And let's wrap up this video. Thank you all for watching.